gRPC is an open source remote procedure and call system. This was initially developed at Google back in 2015, so not long ago, around 4 or 5 years ago. This protocol uses HTTP2 as an underlying transport mechanism, and it uses protocol buffer as the message format. We talked about both of those technologies in this video. I'm going to reference the videos here, but in this video, I want to discuss the following. I want to talk about the motivation of gRPC, because this is the first question that I asked myself when I started researching this technology. Why does it exist? This question pisses me off because I do not like technologies that exist without a reason. And guess what? There is a reason for this technology. It's a pretty good reason. So we're going to go through that. So the motivation of that. We're going to just explain a little bit about client-server communication, some historical stuff here, REST, SOAP, GraphQL, WebSockets, things that already exist. And why didn't we use just existing stuff? Why didn't we have to go and invent new things? Then I'm going to talk about the core problem that we have today and languages have today. And communication have today, which is client libraries. We're going to talk about that a little bit. Okay. Then we're going to talk about why gRPC was invented to solve certain problem. Okay. Then we're going to dive deep into gRPC. As I start talking, you guys are going to start seeing some time codes, so you can jump to the interesting part of the video. You don't have to hear me babble about stuff. Just look at the time code. And I'm gonna always publish it at the first comment and pinned, so you can just jump to the stuff you're interested in. You don't have to watch the whole video. Okay, so I'm gonna talk about gRPC. We're gonna talk about a Unary gRPC. What is that? The traditional request response system, really, which is very, very popular. Okay, so the modes of gRPC, you can play this request response, which is very popular. You can play a server streaming model, like you're watching YouTube, for example, and so the server is always sending you information, but the client doesn't ask for it. Okay, you can flip it, client streaming model, where the client's sending a lot of information, but the server doesn't respond. Uploading a file as an example, right? And a bidirectional WebSocket, right? Chatting, right? So they sat down and did all of that stuff, guys. They solved every single problem that you might have. Okay. And then we're going to talk about coding, which is this is what most people interested in. We're going to start from scratch project, okay? And Node.js, I'm going to use JavaScript for both the server and the client. We're going to build a little bit of to-do application because there aren't enough to-do applications on YouTube, so we need another one. Okay, obviously I'm being sarcastic here. I'm going to talk about the meat and potato, pros and cons, because guess what? There is nothing on life that is perfect. Okay, anything that has pros, you gotta have some cons. If you have like a beautiful, pretty, gorgeous girlfriend or boyfriend, he could be psycho or she could be psycho. So watch out for that. Okay, I am tired of new protocols. You might say this question. It's like, oh, can I just write my own protocol? Jeez, why people keep inventing protocols? I'm tired of them. I'm going to talk about why you shouldn't really invent your own protocol, because some big company actually did and they regretted it, and we're going to talk about the example. And finally, we're going to do a summary. If you're interested to do all that stuff, stay tuned. If you're new here, welcome. My name is Hussein, and in this channel we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing and hit that bell icon so you get notified every time I upload a new software engineering video. And I specialize in backend. I noticed myself, proxies and TLS and security and protocols and things like that. That's my specialty. If you're interested, stay tuned. All right, the first topic here, guys, is the client-server communication, and you guys know about this. If you lived in early 90s or mid 90s or early 2000s, you must have used one of these protocols, right? SOAP was very popular simple object access protocol. And there was one problem that they got wrong, and people abandoned that for that reason. Okay, so it's almost like a RPC, right? You establish a communication between two parties, client and server. The client has to have a library that understands SOAP. The server has to have a library that understands SOAP and XML. The client and server has to agree on schema, right? How would the messages that I'm gonna send looks like, the WSDL, right? And they communicate with each other, right? People love that. Some people hated it, mainly because of the bloated XML, but still, people hated it because of the schema as well. Let's not forget that. Because not everybody like to use a rigid schema. That's why Roy Fielding came up with the REST, representation of state transfer, make a stateless application, and you can choose whatever you want. JSON became popular because JavaScript became popular, and then just guess what? People started throwing JSONs everywhere. And it was very easy. Because, hey, I am client, I'm HTTP client, send a JSON. I don't really need to think about how my schema looks like. Hey, there's a key name and the value, string or date or whatever. I can do anything I want. And this made the barrier to entry almost nothing, and it exploded in popularity. REST. Okay? So client-server communication. Everything is client-server. GraphQL noted some problems with REST and resources and start solving that as well. I'm not going to go deep into that. Still, it's a client, almost like a request response system. It's almost exactly the same. It just minimizes the number of requests that you make by doing server-side rendering, server-side essentially grouping of stuff instead of having you to make multiple requests. And I made a video about GraphQL. Go check it out. Those three didn't solve certain problems, which is, what if my server is actually sending me information, or I need bidirectional communications, not just a request response, right? So these didn't do it, right? People have to invent something that is bidirectional, right? WebSocket was invented, right? And it became a standard, and it's in every single browser. So you can start using WebSocket. But yeah, WebSocket doesn't have a format per se. It just sends a bunch of bytes. You can do anything you want. And yeah, the idea that you can do anything you want became also popular. That's why WebSocket's popular. People like flexibility. Server-side eventing, same thing. The server sends information to the client, right? And instead of bidirectional, it's just almost like server sends information to the client. WebSocket's a bidirectional client and server. And we talked about WebSockets in this channel. I'm going to reference the video here, so you go check it out. Some people didn't like any of that crap, so they invented their own protocol. Databases, right? Most databases invent their own protocol on top of raw TCP. So because you say we like a TCP, sends a bunch of binary, it's bidirectional by default. I don't need to use your protocol, right? I just I'm gonna define my own protocol, message format, and everything. That people use raw TCP. An example of that is Redis. Redis uses a RESP, I think. They invented their own protocol and they packed it into CP in a very compact way. Okay, so a lot of people use that as well. So it's open, right? But here's the big problem, guys. No matter what you choose as a communication, REST, right? GraphQL, SOAP, raw TCP, you have your client that sends this communication and your server that receives those communication have to agree. How do they agree? You need a client library. Guys, REST API. If you want to build a REST API, guess what? What is your client library? It is the HTTP library. And if you're lucky and you're building a web application, you just saved your time, right? You do not need a client library, because who's your client in this case? You guessed it. It's the browser. The browsers are the biggest HTTP client library on existence, right? And you might say, Hussein, why do we care? Client library, right? It's a big deal, guys. Having a client library is a huge responsibility, because yeah, if it's a browser, you don't really care, right? If you make a fetch request or an XHR and you you call a browser method, the browser actually is establishing the HTTP communication with the server. It negotiates the protocol via ALPN. It does the TLS for you. It makes sure that the server actually supports HTTP 2. If it doesn't, it falls back to HTTP 1. It does the headers. It does the streams. It does everything for you. And so you don't have to do anything. You just make your key request, and that's it. Your GET request, your POST request, and the browser takes care of it. But guess what? What if you are not on the browser, which is you're a Go application, you're a Python application, you're a JavaScript application on Node.js, on V8, right? Guess what? You need an HTTP client library. You need a SOAP library. You need a library that understands the protocol you communicate in, right? So in order to do that, you're responsible for the HTTP library, and you must have done that. If you're building a Python application, you import whatever, the request. Someone is maintaining that, right? It's not for free, right? So the request, or curl, for example, similar thing. Someone is maintaining that. It makes sure that it establishes TLS. It makes sure to understand TLS 1.2. It makes sure to understand TLS 1.3 negotiation if you're communicating with HTTPS. It makes sure to negotiate ALPN, application layer protocol negotiation, HTTP 2, and in the future HTTP 3, which is quick, right? It negotiates all that stuff, right? It is a lot of work. Client libraries are a lot of work. And that's what happens, right? A lot of people will use HTTP and a client library on C#, for example, and they will build their own application, and their server is actually a REST API, and then they start building that stuff. But guess what? Now they want their server is upgraded to HTTP 2, and their client library is built by someone who just decided to ditch the library and no longer maintains it. Guess what? Your client library is still using HTTP 1.1. So you do not take advantage thing. If there is a security problem, nobody's fixing your security problem with the HTTP client library. So that's the problem with client library. They are hard to maintain. You need to patch them. If there is a new feature, you have to add these features to your client library, right? There is a C# HTTP client library. There is a Java HTTP library. There's a Python. There's a JavaScript. There is any language must have HTTP library, and it became popular, so a lot of people built it. But still, someone needs to maintain it. So HTTP client library is the worst. WebSockets is the same. You need a library that understands how to talk in WebSockets, right? If you're using browser, problem solved, because someone else, Firefox, is maintaining your library. Chrome is maintaining your library. Brave is maintaining your library. But if you're your own, building your own Python application, then yeah, you have to build it yourself, which kind of sucks, doesn't it? So that's the problem. And there's where gRPC came into existence. It's okay. We can't go on like this. Every time we invent something new, there are a lot of client libraries that comes with it. gRPC, which developed by Google, a lot of people say that it's short for Google RPC, but some people say no, it's not. And I hate when people does that. It's just like, yeah, it's just for gRPC. Whatever. So yeah. So what they did is like, okay, we're going to standardize the whole thing. This is the second attempt. People tried it in the 90s. The SOAP failed. This is the second attempt. And I think people are succeeding, right? There are still problems, but still, I think we're succeeding here. We're going to unify the client libraries. Google or whoever maintains gRPC project is going to build the client libraries for gRPC, because guess what? It's a new thing, right? It's a new client library because we're going to use the HTTP 2 protocol, right? We need a client that understands how to talk HTTP 2. We need a server that understands how to respond HTTP 2. We need a server and a client that understand protocol buffer. And we talked about protocol buffers. They are on schema, kind of binary format. And they said, let's solve this problem. We will build gRPC for you guys. We're going to build it for you. If you use Python, here's the code how to generate it. Just reference this, and guess what? It's gonna build it on and we're gonna maintain it. If there's a bug, we're gonna fix it for you. Someone else is maintaining that. It's kind of like the browsers, if you think about it, okay? But it became this thick thing, right? Thick library, because now it needs to understand HTTP2, and this is also hidden from you guys as a client and server, because in the future, if Google or the open source implementer decided to say, HTTP2 is dead, let's move to HTTP3, guess what? All your client application will just magically work, because they are hiding this from you. They are hiding the fact of HTTP2 backend from you. They are hiding this stuff. Yes, it's stateful protocol, but yeah, they're hiding this stuff from you. So the moment you upgrade your client, right, you use the latest version, you just immediately use that, right? And because it uses protocol buffer, it's now language agnostic. So if you have your client is Python and your server is Go or C#, they can communicate, because the protocol buffer, that's a property of the protocol buffers, where they are language agnostic, right? They are language neutral. That's the correct word, where you compile the proto file into a binary format. And when you send this binary format, it is binary format. Who cares? When you receive it, you deserialize it back into native representation, whether that's Python or JavaScript or C# or wherever, right? So you can communicate with that. So that's why gRPC was invented. It solves the biggest problem with a client library. And I believe that is the main reason gRPC was invented, okay? And you can start seeing some good and bad about this. Let's talk about the modes of gRPC. There are some modes, modes of communication with gRPC, and they are very, very important, because they are trying, remember, this is gonna be one client library, one protocol to rule them all, right? So it better do everything that WebSocket does, it better do everything that SSE does, better do everything that REST does, better do everything that GraphQL does. So how do we make sure that it actually does that? Well, these are the 4 possible communication. Unary RPC, that means a request response. A client makes a request to the server, synchronously wait, and then the server does some processing, maybe calls another service, maybe query a database, maybe just calculate something in memory, right? And then responds with a result. So a request response, you can do that. And we're going to show that example. Server streaming, that's another mode of communication where a client make one request to the server, but the client is expecting a lot of data to come back as a result. Not just one response, multiple response, a stream of response that will just flow from the server to the client. Example, a YouTube video you're watching. You make one request to the page, but a flood of data is coming back from the server to the client. I'm not saying that YouTube uses gRPC in the front end, right? But it's just an example of things you can do with server streaming, right? So the client gets essentially a handle of this and says, hey, he listens to an event on data received, do this. And every time the server sends the data, the event gets triggered, and then you get the data. Just like WebSockets, exactly like WebSockets if you built those. Client streaming, exactly the opposite, where the client is constantly sending information. An example is you're asynchronously uploading a huge file, right? So uploading a huge file is basically, it's going to take a long time. So you better upload a stream. You connect a stream with a server and then just write to that stream. Hey, chunk 1, chunk 2, chunk 3, chunk 4, until you're done. This way you can also stream some progress and do all that fancy stuff. And server can optionally respond or not. Depends up to you, right? If it finishes everything, the client can send, hey, this is the last request, and server's like, okay, I'm done. I got everything you know. And bidirectional streaming, both of those guys communicate to each other in an ad hoc manner. Chatting is an example, like gaming is another example. If you're using lockstep approach, right? Because the lockstep approach is very chatty, right? Unlike the server authoritative model. Right, so that's another kind of use case. Coding time. Let's do this, guys. Okay, so I tried to come up with the simplest example for gRPC. And I decided to do a to-do application because, yeah, it's very easy, right? It's just very easy to understand. And it's not so simple like the examples that are on the gRPC website, which is hello world, which confused me actually more. If you, that might be just me, right? But I was confused more when I saw that. It's like message and server hello. Why would, yeah, it was very confusing to me, right? Yeah, it was way too simple that it actually confused me. It was that bad, right? So we're gonna do an application, a server and a client using gRPC to communicate between the two guys. And what we're gonna do is the client is gonna call a function on the server called create to do, which will create a to-do list like, hey, do my laundry, hey, take my dog to take a bath and whatever, right? Walk my dog, all these things, right? And the server will actually write that to, I don't know, I'm gonna write it to memory, but you can do it in the database as well. I'm gonna write another method using the Unary. This is also Unary gRPC, which is request response. Right? When you make a request, you're gonna get back a response with the to-do and an ID. Read to-dos. We're gonna do it synchronously here, where I'm gonna make one request. I'm not gonna send any information, but as a back, I'm gonna get all the to-dos that I have currently on the server, and that's also powerful. But there are some limitation to that because you'll have to build all the payload, all the to-dos, and send it as one request. That could be expensive and slow. That's why I'm gonna also do a server stream model where you make one request and the server streams the to-dos, like 1, 2, 3, 4, and the client, every to-do you receive it, you can do something with it, right? So we're gonna do all these kind of things. If you're ready, let's just jump into it, Philip DeFranco. All right, guys, so let's use Node.js and Visual Studio Code to build a server application that will host my to-dos. They will have the method called create to-do. They will have the method called read to-dos, and a client, obviously, to actually consume that stuff. I'm using the same language, JavaScript, on both, but you can as simply use Python as a client and server as a backend. And maybe I'm gonna make another video to do that. Okay, it is because protocol buffers is a language neutral. You can actually do that. Okay, it's a property of protocol buffer. How about we jump into it? Let's build a new protocol. No, let's not build a new protocol. Let's build a new folder. JavaScript Playground, create a gRPC, right? Just a new folder. And then open that folder. And then let's go ahead and initialize npm. So let's go ahead and initialize npm just to get started. Npm init-y. Brand new project, brand new everything. And here's the first thing we need to build, guys. We talked about protocol buffer. I'm gonna reference the video, guys, but this is the communication, right? Because if you're building something, right, between the two using gRPC or protocol buffers, you have to build this proto file, this schema, right? So that's what we need to do, right? Let's go build to-do.proto, okay? And then what we need to do is / a syntax equal proto3, okay? Because that's the latest and greatest protocol buffer version. The next thing we need to do is define a package name, and I'm gonna call package, let's call it to-do package, right? And the reason I'm doing that, I named it package so we can know that if we received it in the code, we know that this is the package. And this package will include multiple services. You can build multiple services here, okay? And in this example, we're gonna build one service, right? And this service is essentially the to-do service, which will serve our to-dos, right? So we'll have methods in our service. So how about we build that? In order to build the service, you specify the keyword service. And we're gonna call it to-do capital letter here, okay? And there's a service called to-do here. And the first method, which is called RPC, we're gonna create our first method. And what's the method we said? We're gonna call it create to-do, a single to-do, okay? And that takes some parameter and that returns some parameter as well, some return thing, okay? What is the return type that we expected here? We expect to return one single to-do item, right? So we can call it, we can create a message, called to do item, right? That makes sense, right? And what's in this item? An item has an ID, right? And this is integer 32, ID equal 1. And it's also have a string text, which is, this is the ID, like maybe you have a column on your database that you store the to do with an identifier, right? And then you have a text that essentially identify the actual to do item, do laundry, whatever, right? And this is 2, okay? And what we want to do here is to return a to do item here, okay? Because that's the thing. We're gonna create a to do. We expect you to send me the to do text, basically, right? So it's just literally a text string, nothing more, right? So we can define another message, right? Called like just text, or we can actually use this, because why not? We don't know the ID when you send it, right? But we can just use a -1 as just thing. Or you can as easily just create another message called just text, right? That receives a text, okay? That's cool. The other thing we need to do is we're gonna create another method called read to dos, okay, with an S, right? And this thing doesn't actually take anything, right? Just doesn't take anything because, hey, just give me all the to-dos I have, right? And this returns to do items with an S, right? Which is another message that's called to do items. But guess what? What is the type of the message itself? There is a to do item type called items or to dos, right? That's exactly what we have here. And this is obviously equal 1. But remember when we talked about protocol buffer, this is an array. How do you do array in protocol buffer? Repeated. That's how you do it, right? Cool. And here's the ugly thing about Protobuff, right? There's nothing called no parameter, like void in C, right? You have to specify actually a message that is no param or void. Let's call it void. Literally just that does nothing, right? And then specify that. Make sense? So that's essentially, we have the service called to do, we have a package to do, which could have multiple services. I just have the one, right? We have 2 RPC methods, create to do and read to dos, and we have a void message for some reason. And the to do item, ID text, and an array of to do items. How about we actually build this thing? This is now proto file, right? And remember, guys, when we discuss the proto buffers, we talked about all this proto C thing that Google maintains and the open source community maintains that compiles the proto into your favorite language. Guess what? gRPC uses something very similar that actually uses the protocol compiler that actually simplify your life. It does all that stuff for you, which is awesome. Okay, because remember, it took us a while to figure that out, the Proto C, and figure out which one to download for your operating system. It does all that for you, which is awesome. All right, we have a Proto file. That's not enough. Let's build our server. Server.js. This is the server. So you're expecting some listening to be happening here. We're listening to a server. Time for the libraries. What are we gonna use? We're gonna use, obviously, a library called gRPC. And we have to require, because we are Node, gRPC. So we have to install it, which we will do in a minute, okay? Another thing we're gonna use is something called a proto loader, which is exactly the same thing we discussed with protocol buffer. You have to compile the proto into a bunch of JavaScript files that will actually have your schema and the getters and setters for your schema, right? And for your Python, does the same thing. For C# does the same thing, right? Proto loader does exactly that for you. So we're gonna do require, I think it's called gRPC proto loader. There is a dash there. Yeah, there's a dash. Proto dash loader, okay? All right, so we have that. How about we actually install these two things, right? So quickly install so we get IntelliSense, beautiful IntelliSense, right? npm install gRPC and at gRPC/proto-loader. Go ahead and install it for me. Okay. Do we get an error? Why did we get an error, sir? It says refusing to install with gRPC under a package. Ugh. All right, guys. We did a mistake. We should have never named our folder the same as the gRPC, which is something Node doesn't like. So I'll go ahead and just go ahead and rename our folder to something else. So that. All right, guys. So I renamed my folder. I renamed my package.json. Hopefully now it's not gonna yell at me, because I installed it npm install gRPC add gRPC proto-loader. Ooh, finally. All right, so we have installed the necessary library. This actually uses proto.js, which actually does the compiling for you, which we're gonna show in a minute, because that's the next step. We need to basically compile this stuff, right? So how do we do that? All right, so first thing we need to do is we're gonna create something called a package definition, which will use the proto-loader, right, to actually load synchronously, because I'm not in the mood to do then catch, right? And we can pass it the file name of the proto file, which is called todo.proto. I really recommend you guys watching the protocol buffer files. And here just pass an empty object. You don't really need to specify anything else. This is the initial configuration that tells you, hey, how do you want me to treat case sensitive schema versus how do you want me to treat long and 9 use the default. Most of the time you're gonna not use any of that stuff anyway, right? So we're gonna take a package definition file. Now that's not enough. We're gonna load that package definition into a gRPC object, right? gRPC object. So the whole goal of this is to actually obtain the package that is this to-do package. We want that package as an object, right? And to do that, we need to go through a lot of humps in order finally to get it. So what we're gonna do is use the gRPC something called load package definition. And you're gonna pass it the package definition, which you just got from the protocol buffer file. And that will nicely load that package with the schema and all that fancy stuff. Now finally, here's how you go get the to-do package. We can declare a to-do package, gRPC dot basically dot to-do package. Just like that. Just like that, we got the to-do package as a package. Now we can instantiate the service, we can get access to the messages, we can get access to everything. Now we got the actual protocol object, the full object, right? The package, which we have access to everything inside. Next thing is, we're gonna create a server. How do we create a server with gRPC? We're gonna create a new server equal new gRPC.server. And that's just its cap. So once we create the object server, well, if we know a thing or two about servers have to listen to essentially a port and an address. So what we're gonna do? Server to bind it to what? 000. And guess what? There is no protocol that we need to define here. Just listen on every single interface. You can listen to the local host if you want to, but here you use this if you will have an external IP address that you also want to listen to. And which port are you gonna use? I'm gonna use 40,000, whatever, right? A port that actually hopefully no one is using. And when you do that, when you're listening as a server side, we're using HTTP2. Guess what? HTTP2 by default needs credentials. It needs to be secured. That's one of the goals, right? But gRPC allow you to bypass that. And in order to do that, you can do .server credentials dot create insecure. We want just an insecure one. And I'm gonna make another video to actually discuss how you can make a secure one using essentially the create SSL, which you pass in the certificate, and we're gonna do all that stuff hopefully. Create unsecure. For that, let's just use unsecure one, right? Which means the communication between my services will be plain text, but who cares? Okay, server to bind. That's the first thing. Remember guys, these two lines of code have no idea about your service. So how do you actually tell your server about what services you're using? And we built one service, remember? And it's called a to-do. How do I give my server a service? Is there something called add service? How about that? We need a service definition. And from where we get the service definition? There is a package, right? And there is dot to do, which is the service, right? Dot to do, which has to be case sensitive, I think. To do dot service, because the whole definition of the service, you need the actual service object, right? So that's what you do. The second parameter is actually interesting. It's a JSON object, right? Because you're adding a service that has a bunch of methods, right? This is the method. Method called create to-dos and method called read to-dos. Well, where are your methods, son? Right? You have a bunch of methods, but you didn't map them to something that you have existing here. So, well, that's fair. So we need to create a function called create to-dos. And it does not have to be the same name. You can give it any name you want, but for consistency, we can do it there. The key is the name of the service, the method here, and the value is the actual method object, okay? It's a function. And the second one is what? Read to do. So I'm gonna copy it and we're gonna create a function called read to dos that doesn't exist yet, but that's no problem because we're gonna create read to dos. All right, sweet. And here's the thing about functions that use gRPC, right? So almost we're building that structure, guys. We're building it, almost there. Let's finally do server.start, which will actually start listening and do all that fancy stuff. How about that, guys? Okay. All right, guys, make sense so far? That makes sense, right? Let's just do this so you can see the whole thing. We're listening to the port. We're adding the services. Now we have a mapping. We start listening. So we can actually start listening and a client can actually communicate and do stuff with it. But here's the thing. Our methods are empty. They are not doing anything. Methods in gRPC always takes two parameters. An object called call, the call that made, it's not an actual request, it's the whole call because you got access to the whole thing, the TCP connection and whatnot, the whole thing. And a call back that you can use to send back response to the client because that's the client, that's you sending information back to the server. So we can call, this is essentially a function that the client will be listening to, right? Same thing here, call back, right? And for simplicity, we're just gonna do console.log and do call here, right? Just we're gonna print the call that we get back here. So we can see stuff before we actually implement those stuff. All right, guys, I can start listening that right now, but there's nothing to actually consume that. But how about we run it and make sure we don't have any errors. Start debugging. And we got an error. It says cannot read property to do of undefined. Ooh. Well, first of all, this should be gRPC object, not gRPC, right? Let's start that. There you go. That was it. All right. So now we're listening here. We're ready, guys. We're ready. And I'm going to put a breakpoint right here so we can listen and capture this thing. Okay. That's the server. How about we create a client? Client.js. The client.js is exactly the same because it needs to understand the proto. It needs to understand everything, right? It needs that object, the gRPC object, and the package and the service and all that jazz, right? So we need these line of code. Exactly. Paste them here. Okay. We need them. But the client actually connects. So when the client doesn't listen, right? The client actually connects. When to connect, you need what? IP address, port. Because it's cell, it's TCP, right? So what we need to do is to create a client object equal new client to-do package, what we're going to create an object of the to-do service. And by doing that, we need to specify two pieces of information here, right? Which is, what is your port? An IP address, localhost. I'm listening locally. And what was the port? 4,000, 40,000? Yeah. Was it 40,000? Yes, 40,000, right? You can as simply did localhost as well. That works as well, right? But here I'm communicating to the localhost, or you can use the IP address, or you can use the host name, okay? And similar thing, we need security. So you have to tell it specifically that, by the way, I am actually, my credentials is insecure. But you don't use server credentials this time, you use client credentials, so it's kind of different metadata. Okay, so gRPC.credentials.create insecure. And just like that, we have a client. And what do a client do? Well, they can call methods. And guess what? By doing that, so we can call create to do. And the create to do function, if you go to this definition, what does it take? It takes a to do item. And what does it look like? It's an ID and text, a number and a string. Well, and that's the beauty about this. I love this so much. I don't need to create intermediate classes or anything. Just passing an actual JSON, gRPC will understand what you mean. It needs an ID? Sure, -1. Because again, I'm not creating the ID. I'm about to creating the whole item. So I don't know the ID. And what's the other property? Text? Was it called text? Yes, text. So, let's call it laundry. Do laundry, right? Create one item, and that's it. When you call this function, you take two parameters. The first thing is what you about to send. The second thing is a function that takes two parameters: the error and the response from the server. Okay, so the error is actually what happened. If there is an error, the response actually what the server sent you, what sent back to you. So you can do console.log received from server. You can do JSON.stringify response, because I don't know what I'm gonna receive from the server. So I'm just gonna print it directly. Got it, guys? Makes sense? Cool. So we can do that, sending an object. That's it. How about we actually test this beautiful client, huh? So the client wasn't that hard, huh? Let's do it. Let's do it. So what we're gonna do is I'm gonna listen on my server here. So my launch.json is actually listening, and my client, I'm gonna go to the terminal and undo this. Guys, I'm gonna do this. Let's clear this. Clear. I'm gonna do node client.js. Just execute my client. And the moment I executed my client, the client started doing all that stuff and called the create to do method. And it actually, here's the breakpoint. So what did we receive from server? This is what we received. We receive a call object. This is the call object. And there is a request. That's the request. And the request is the actual object that we exactly sent, which is an ID and a text. How beautiful is this, guys? And this is all compressed binary format. Obviously you cannot see it, but it is. So you can just take our word for it and take the value. And then how about we store this somewhere, right? Let's just start storing all this beautiful stuff that we receive from the client, right? So I'm gonna create to-dos array, and then just like that, I'm gonna do todos.push call.request, because the whole object is what we want to store, right? Because request will be an object of ID and name. No, we do not want to do that, right? We want to create a to-do item, right? Object. And what will be the ID of this item? This is a brand new item. The ID is .length +1. And the name or the text is actually the call.request.text. And then I want to push this puppy, right, to the array. And just like that, we built the array. And if I push something here, this is gonna be, initially this will be 0. So 0 plus 1 is 1. The first item is 1. The second item will be 2, and so on, right? So I'm cheating here. I'm also using a database. I'm just using a memory, and that's just an example anyway, guys. Probably you shouldn't do that, but you get the idea, right? Just showing you the basic building blocks of things here. We got the to-do items, and that's it. I push it, but we didn't tell the client that we actually are done. So how do we call the client back? That's how we do it. You do call, and you specify the length of how big is your, essentially, is your payload. Just say null, because it will be auto calculated. If you do null, and then you send back the to-do item, literally just send it back, okay? Sweet. What did we do when we say the client will receive something? The response will be, this function will be called, right? The client to do. This function will be called, the response will be called, and we're gonna print whatever we receive from server. How about we do this thing and make sure that it actually works? We're gonna do node client.js. Send one request to the user, and we got back ID 1 text do laundry. Let's do it again. Wow, this guy, my wife really wants me to do the laundry. I'm not doing that. Look at that. The same text all over again, right? Obviously, guys, you can do something like that, right? So it's like cause text equal whatever process dot argv. Is that what it's called? So 1, 2, right? 2 will be essentially the third parameter, which will be the actual text. So let's try that. Blech. And then, oh, the server is down, I think. That's why we didn't get back anything from the user. And let's send walk dog. We get it, right? It's clear. Node.js, node client.js, and send, I don't know, laundry. Yes. I'm not gonna add a space because this is gonna screw up with everything. But you get my idea, right? And I don't know, study. That's another to do, right? Blah. Right, so we're sending to-dos and the server is storing those to-dos, but how do we read them to-dos, guys? How do we read them to-dos? How can we read them to-dos? Well, same thing, client.read to-dos. And read to-dos literally takes nothing, I don't really care. So you can send empty object, because this is the void thing we talked about, right? And it takes back a callback, which is the same thing, error and response. And when someone calls back, you can do this. Can exactly do this. Blah, blah. Good. Just print whatever you receive from the server. So I'm expecting this function will return all the entire array of stuff. How do we do that? Remember, we didn't implement anything in this function, right? And what we're gonna do is return the whole array, which is probably not a good idea, right? If you're building, it's like if you have like 30,000 to-dos, you don't want to return them because that will be a lot of processing on your backend and will be extremely expensive, right? So you want to stream them to the client and let the client acknowledge them every time you receive something, right? We're gonna show that, but let's do the boring stuff first. Call, I don't really need to do anything with the call because I'm not expecting it. I just need to send back the user, right? Which is literally just call back null. And what do we want to send? We're going to send back the whole array, but you can't send the array like that naked because, can you guess why? Because it's expecting an item of type to do items. So you need to send an object which has a to do items object key, and you send the to-dos here, right? Because that's an object. That's what is expected. The schema have to be exact did match. Let's see if we screwed up, guys. And gonna do laundry. Boo! Failed. Void. An unexpected token void. I have a feeling that I shouldn't have used the word void. Maybe because it's reserved. So no params. I'm gonna call it void no param, something like that, right? All right, guys, so the problem here is this object has to match this guy in the to-do items. Items, right? Not to-do items, should be items. That's the trick here, because that's the actual object inside. Now, let's run and test this thing. And I'm gonna sleep. And I need to read. Nice, nice. We get another thing. Walk the dog. Nice. We're getting this and that. That makes sense, guys, right? Because like we're getting back an array now, which is awesome. We can do this array, take it and play with it, loop through it, do anything with it, really. Because that's what we do with the client, right? The client can just literally take that, and we can actually play with that. So let's not just do that, right? We can do this. Response dot, what are we expecting back? Dot items, right? Dot items dot for each I, and then do console.log text. Just print the text, right? Let's see. That should just work normally, right? All right, so that's just an example that you can actually loop through it, do stuff with it, right? Cool stuff, guys, but this is the bad idea where you take the whole array and shove it down the client's throat. How about we actually do the streaming, where the server actually streams stuff back to the client? How about we do that? In order to do that, what we need to do is define a new function, and we're gonna call it read to-dos stream, right? And what we're gonna stream back, not an actual repeated array, we will return back a stream of type to-do item. That means it's like you get one item at a time, right? But it's streamed to you back. So that's the first thing we do. Okay, the client has to call it and the server has to map it, right? So let's map it in the server. In the server here, this method is this method, which doesn't exist obviously. So what we're gonna do is function, create this, and same thing, this call and a callback, right? But there's some magic here that we're gonna do. It's a stream. And the function, the client here, what it does, it literally says client dot, we're gonna call the same function. But here's the difference. It's not a callback anymore because you're not expecting something back as a callback function. You are getting a call object, right? And then do we need to send anything? Nah, we can just send nothing, right? When you do that, you can start sending to events, guys, here. On the events, and when the server sends data, you just take the message, which is essentially, guess what? It's an item. And then you can do console.log. If the server sends me some data, received item from server, and then you can do JSON.stringify item, right? Receive this item. And at one point, the server will end the communication, right? So you need to define the end protocol, which is essentially just does nothing, right? So yeah, console.log client done, or server done, I think. Yeah, server done. This is the communication on the client. How about the server? Where's my function, the server? The server is called read to do stream. And what we're gonna do here is use the call that we got back from the client, this call object, and we can write directly to it some cool stuff. So how about we do that, right? So what are we gonna do? We can literally just do todos dot for each, and for each t, literally do call dot write t. Write it back, son. Write it back. And when I'm done, guess what? Call dot end. Just end the communication. between the client and the server. So that's a better approach. And you can write something and wait for the client to process for a few, I don't know, milliseconds, and then write it again. And then this is a beautiful way for streaming, right? Because you can measure things. You don't shove everything at the client's throat at once. You actually take it slow with the client. It's like a first date. It's the first date. Guys, take it slow. Take it slow. All right, let's do the client here. What does the client do? Ooh, the client's gonna do a lot of stuff. Boop, 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 boop. We're gonna do a Node.js. Let's do read. We're gonna get an error. Oh, what did we do? Oh, this is wrong. It says, okay. I think I need to protect this. Sometimes this could be null, so we need to just protect this in case this is undefined, right? Because it could be, right? If there's nothing. If it's not undefined, then do this, right? All right, we're reading, we're sleeping, we're napping. Cool, we're getting something from the server, right? We're doing all that stuff. Receive item from the server, receive item from the server, and then server done. So we're receiving information, and we can just commit this function, guys. We don't have to call this a million times, right? We don't really need this. All right, so now if I do this, let's do walk the dog. That's what we got from the server. We got receive item from the server, 1, 2, 3, all of them. We're receiving it one by one, right? And this is the item for the actual write, right? That's what we write. Okay, so this is pretty cool, guys. This streaming idea is awesome. So you can stream stuff from the server back to the client, right? And then whenever you're ready, you can display this item. I'm gonna reference the code, guys, for you, so you can check it out and just feel free to use it, right? And how about we go back to the slides and finish this course? All right, guys, are you ready for the pros and cons? So we did the code, took us a while, but we built a server on gRPC, we built a client on gRPC, and we communicated with them, between them, as a Unary protocol, as also a server-side streaming protocol, which was awesome. So we built a nice to-do list application, which is like a very basic stuff, right? From that, we can build more and more cool applications, and you can start thinking about that. How about we talk about the pros and cons of gRPC? Because guess what? Nothing's perfect. Let's do this. So the first pros is actually it is fast. And when we say that word, fast, I know it's not just a marketing word, right? It is fast because of a reason. It's compact, right? We're using protocol buffer, so everything is a binary format. So we're not sending JSON across the wire. We're sending this slimmest format possible, which is the binary. And HTTP2 actually compresses even more, so it's actually smaller and smaller, which is awesome. That gives us the speed, right, when we communication, because if your payload is small, then you don't have to do this extra round trip on TCP, because your MTU, maximum transmission unit, has a limit, which is, I believe it's for the internet is 512. What was the MTU? Let me get the actual number. So I'm reading 1500 bytes, right? So that's the MTU. So the less this happens, the better, because you can transfer everything in 1500 bytes, which is awesome, right? And instead of going and doing another round trip to transfer the rest of the data, right? This is expensive, right? So the most compact, the faster, right? And this is the most important thing. It's one client library. And when I say one, it is one per language, right? And it is essentially that language, every language you use will have very similar gRPC client library that maintained by Google and other companies in the community, in the open source community that manages the gRPC protocol. So if you have Python, you make sure you're going to use the gRPC one client library. You don't have to maintain it. Someone else is maintaining it for you. Okay, so every security patch, every upgrade, every feature, everything, you get it for free. which is awesome. So you don't have to maintain it yourself or just rely on a third-party client library like SOAP or REST. Even REST, there are many HTTP client libraries, right? And that diversification can lead to problems because if you have so many stuff, right, it will be hard to manage essentially. So one client library, and this client library, essentially there's multiple versions for every language, almost every language, right? You can build the progress feedback, right? Because there's server-side feedback, server-side streaming. For features like upload, for example, you can add a progress bar, something you couldn't do as easily with REST, right? You have to do some certain pinging and fetching and polling in order to do this progress. Like, hey, I'm uploading a 30 gigabyte file. Right? How do you do a progress bar? You can do it with gRPC, right? You can essentially simulate it because the server actually can send you information, sends you streams. With HTTP 2, which is the main protocol for gRPC, you can actually cancel a request, something you can never do before. Canceling a request was impossible because what does it mean to cancel a request, right? Because how do you know? Because in a stateless environment, it's impossible to do that, right? That's why gRPC is obviously stateful, right? If I make a request, HTTP tags every request with a stream ID. And when it does, the gRPC can actually, if you want to cancel a request, you can tag the same stream ID, says, hey, I want to cancel that. So the server actually can possibly hook into that cancel event, and obviously you have to write the code to cancel whatever that means, right? Close the connection or give up trying or do something, right? You have to write the code to cancel, but this gives you the hook to actually listen to canceling event, okay? Which is awesome. Something you can never do. With HTTP 1.1, it is impossible to cancel requests, right? Nobody can actually tell you that. If someone tells you, hey, you can cancel HTTP requests, they're lying. You cannot. You can cancel from the client, you can give up waiting, but the client, the request is still churning on the server, right? Because what the heck does it mean to cancel? It's there. It's a stateless, right? Because your next request will gonna go to another server. How did you know? To hey, by the way, that server I sent, that request I sent like three minutes ago on server or whatever, nah, it doesn't work. HTTP 2 and protocol buffer benefits just magically appear here. All the benefits for protocol buffer, compact, fast, all that stuff is here. All the benefits for HTTP 2, streaming, bidirectional, push notification, right? The idea of compact compression, right? All of that stuff, you benefit from it if you use gRPC. Let's talk about the cons. What's bad about this? Nothing. Oh my God, look at that. The first thing, I'm not saying this is all subjective to my opinion, guys. So chill, okay? Schema, I think it's a cons. You forcing me to do a schema? I mean, yeah, it's way easier than just doing plain raw protocol buffers because that creates classes and just ugly stuff like that, right? But still, I don't need a schema. I'm just building a REST API application. In the day of REST, I didn't have to do any of that garbage. I just send a bunch of unformatted messages and it's JSON, and I don't have to specify a schema. And unless the client, if my client understands, just checks for a certain value, just reads it. I don't have to maintain a schema. I don't have to maintain a proto file and a schema and all that stuff. Some people find this a turn off, to be honest, right? A lot of people moved from SOAP to REST because of the schema. You forcing me to do a schema is not necessarily everyone. Not everyone was gonna like that. I read somewhere that actually gRPC can actually work with JSON as a format. I'm not sure how, right? But that would be awesome. gRPC will be perfect in that case, for this case. No matter what, you're maintaining a thick client. And that thick client, you have to make sure to update it from now and then. I mean, yeah, every time you run your application, technically the proto-C file is getting executed and compiling your stuff. I might be wrong there, but I don't know the implementation of gRPC. Every time you run to actually, do you compile the proto file every time? That could be expensive, but they could be. If they do that, then it's a thick client, right? You're maintaining this thick client that you need to patch. You need to continue add features to it. I mean, you're not doing it, but you have to make sure you are responsible to update that, right? If something happens, right? And yeah, it's just a client that sits with you. I mean, yeah, it is the same language as you, but sometimes you can use a language that is not supported by gRPC. Yeah, guys, yeah, gRPC doesn't support all languages. There are certain languages this supports, and I'm going to give you the list. C#, Go, I think, JavaScript, Node, and some C, something like that. Not all of them, right? If you're using like Ballerina, for example, tough luck, right? Using gRPC. Proxies, yeah. Guys, remember? TLS terminating proxies? If you're using a layer 7 proxy that needs to look well, and you're using gRPC, there's no way that this proxy, unless it proxy understands gRPC. I'm aware that some proxies are now. I know Nginx now added support for gRPC. HA proxy added support for gRPC, but yeah, not every proxy actually knows the gRPC, right? So proxies are still learning about this protocol. It needs to understand it. It needs to terminate gRPC, which, what the heck does that mean, right? Terminating gRPC and reestablishing it on the backend, right? That's why it's way easier just to use a layer 4 proxy with gRPC and just call it a day. You cannot hook into the gRPC request. I don't think it make any sense to do so, to be honest, right? To actually listen to the gRPC request and do something with it, right? I might be wrong there. But yeah, proxies are still learning about gRPC, right? If you wanted to do at least a layer 7 proxy, a layer 4 proxy doesn't have to, right? There's no problem, because just it will tunnel the TCP request, right? The gRPC request with proxy, I think it will listen to the first request, and I'm not sure what is that exactly. It might be an ALPN, right? Because ALPN is part of TLS, right? Which kind of negotiates HTTP. Maybe part of that is actually tells the server that, hey, by the way, I am gRPC. There's some sort of a header that tells the first request that, hey, this is actually a gRPC. So maybe the proxies will fall back to a streaming model when it does that. So it's still young. So there will be a lot of bugs. There will be a lot of stuff that is bad, right? You will have to follow up with support, right? If you run into a problem, you might not just find a solution in Google, right? Because it's very, 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 very young, right? If you have a bug, you might actually have to fix it yourself if it's not in Stack Overflow, right? Error handling still a pain, right? Because remember, it doesn't use HTTP codes, just like GraphQL. It doesn't use the raw HTTP codes to demonstrate anything. It uses, you have to build your own protocol essentially to maintain errors, and good luck with that. It's painful, right? So you have to build essentially your own error handling, and that is proved to be very, very, very difficult, right? Because again, this is like building a brand new protocol, and I'm not sure what gRPC are doing to solve this problem, to be honest. And yeah, there is no support for browsers. There are some hacks. People use proxies, and that essentially takes a request and a normal HTTP request and make it into a gRPC to the backend, right? So debugging is so hard with this. You saw me what I was doing, right? It was just like I have to write a code to debug and run here and run on the client. It was very difficult to debug, because unlike the browsers, like if you're building a REST API, just go to the network and see all the calls. It's very simple. But gRPC cannot run on browsers because it uses a protocol buffer, guys. And what the heck is protocol buffer have to do with websites? There's no schema on the web. The internet has no schema, guys. So yeah, that's example. That comes back to this problem. I'm using the internet. There's no schema. It's a bunch of blob of HTML and JavaScript. So gRPC doesn't fit on the web. Unless you want to treat the whole thing as a blob, right? I mean, you can do that. Why not? But yeah, that's one of the problem. There is no support for browsers, which sucks. Okay, maybe someone will do a solution for that. I really doubt it. Really doubt it. That was gRPC is gonna come to browsers. It's not gonna happen, guys. And timeouts, guys. Right. So if you are a client and you make a request, right, and if this is a Unary server request response, then you'll have to wait for a result, right? And if you're waiting, how long should you wait, right? This come back to the timeout, client timeouts problems, and circuit breaking, right? Especially with microservices. Service A calls service B calls service C calls server D, and all of them are gRPC. Guess what? Service A is waiting for a result from service B, which waiting for a result from C, which waiting from D. And you're gonna manage this mesh, essentially, the topology of the microservices yourself. And it's extremely complicated. Okay, because what happened if one of them fail? And what happened if a request is taking too long, right? Or yeah, should I continue waiting? Should I quit? Because all of this is resources that you have to manage, right? And PubSub doesn't have this problem. PubSub is actually good stuff, right? With PubSub, the client and server are decoupled, right? Almost like REST. You make a request because it's like kind of a stateless, right? REST, right? But PubSub is not really stateless, but stateless C, right? Where you push a message to a broker and the broker will listen, right? And will just shove the message and you're done. The moment, if your message reached the broker or the queue or whatever you want to call it, Kafka or RabbitMQ or ZeroMQ, that's it, you're done. You are done, right? There is a subscriber that is responsible to subscribe to the broker, and whatever the communication between the broker and the subscriber be, push or pull or long pull, that's another story. But they were gonna get it eventually, right? So it's better. I know I made a video about PubSub, guys. I wanna go check it out. All right, Hussein, screw this. This is too complicated. I'm gonna build my own protocol, and it's gonna be awesome. It's gonna be coolish, not cool, right? Because you don't want to be cool, guys. Remember, this is the spectrum of coolness. There's all the way bottom, not cool. There's all the way top, cool, and there is right before cool. There's coolish. Right? You will never want to be cool, guys. You're just trying too hard. The cool kids, the Gen Zs, will just, they will see you. You're trying too hard. You have to be coolish, just below cool. Just like, just trying. Just be coolish. Coolish is the state of mind. You want to be coolish all the time, right? So that's what you want to do, right? Back to the point. Okay. All right, so I'm gonna write my own protocol, Hussein. I'm gonna use my own stuff. I'm gonna use bitwise operators. I'm gonna compact all my messages in 64-bit, right? Just 64-bit. Everything. I'm gonna shove everything in 8 bytes, right? And that's I'm gonna build my game using my own protocol. I'm not gonna use those garbage gRPC. Good luck. Go do it. Spotify did. Spotify built their own protocol from scratch. That is called Hermes. And Hermes is the messengers of God, the Greek god, right? If you play God of War, he's the fast guy, that one of the bosses that you have to kill, right? But, they did that, guys. And guess what? They end up using gRPC. Not because Hermes sucks. Hermes was awesome. They built a badass protocol compact, everything. And they have their own protocol, their own method, their own error codes, everything. But guess what? They have to throw it all away because every employee that joins says, okay, what the heck is Hermes? I never heard of it. They just say, I have to learn this language, they have to learn how to protocol. But the moment they leave the company, it's useless because nobody's using Hermes except Spotify. So, and plus when they want to communicate with outside services, nobody understands Hermes, right? So nobody's willing to integrate with them. So integration becomes very hard, but it's a perfect protocol. And you can do that too. You can build your own protocol. But if you want to go with the wild and everyone else, gRPC looks like it's the future, guys. I'm not gonna lie. I'm a kind of a pessimist, but in this case, I kind of have to agree with gRPC. Bite the bullet, use the schema, and just run with it. If you're rebuilding microservices or internal applications that talk to each other, use gRPC. I'm not sure about web application, doesn't really apply much, but you can build it as the back end. Yeah, so they moved from Hermes to gRPC because of that, right? Because they were very isolated, their own bubble, right? Summary. Finally, we're done. How long was that, guys? 3 hours? All right, so we talked about the motivation of gRPC because guess what, guys? There's always a reason of doing anything. And if you have a technology, and I always struggle with this question, the first question I ask myself if I see a new technology is, why is it available? Why does it exist? And if I can't answer this question, I call BS. Okay, that's just me. I call BS because everything has to have a reason. If it doesn't, if there's no reason for it, it was just like, oh, it's gonna make my life 3% better. Ugh, probably no. So yeah, that's the motivation. There was a problem with the current architecture, the client server, certain problems, and mainly it's the client library, guys. Just fix this problem that I have, right? I don't want to upgrade another HTTP library, right? If I have a desktop application that uses HTTP 1.1 client library on C#, the moment I upgrade my server to use H2 or H3, I have to upgrade all my clients. And that's expensive, guys. Okay, what library should you use, right? And you have to maintain this HTTP 1.1, and there is a security bug, and there's, I don't know, HTTP smuggling bug that you have to fix, and then it's ugly fixing bugs, right? So it's really hard. That's the problem with client libraries. So yeah, that's why gRPC was invented. Fix the client libraries. Get one client library to rule them all. We talked about Unary, gRPC, the client response. We're going to talk about server streaming, and we actually showed it. Client streaming, we didn't show it, but it's the same thing. Just use a stream protocol buffer keyword on your request, and that's it. And let the server listen on this time, not the client. Bidirectional, you can do bidirectional as easily. We did some coding, we showed all that stuff, guys. We talked about the pros and cons of gRPC. Let me know what you think, guys, if I'm full of S, right? Trying not to swear here on YouTube. I am tired of new protocol. We talked about that, right? It's just like, hey, I don't want to learn this gRPC. I want to go my own way. Try, you can try. People try before you. Spotify tried. Hermes didn't go so well, right? It was going well, but they couldn't evolve, right? And every features that gRPC added, they have to add themselves, right? Because they are alone. They are by themselves. And finally, we summarize the whole thing. Guys, what do you think of this course? What do you think of this video? If you like it, give it a like, share it with your friends, and I'm gonna see you in the next one. What should I make next? Write in the comment section below. And yeah, this video took me 2 months to research, right? And I'm really happy. I'm really happy with the progress that I made. I'm pretty sure I missed some stuff. Do let me know if I said anything that is dumb or wrong, because I'd love to be corrected if I'm wrong, because that's how we all learn, guys. I'm gonna see you in the next one. You guys stay awesome.